You are welcome to my channel. In this video, we want to reproduce the figure that is displayed at the right hand side of the screen in orthographic projection. But the kind of orthographic projection that we'll be reproducing this figure in will be in first angle projection. As we move along, I will explain to you what's the difference between the first angle and the third angle projection. Now let's start. Now when you hear the word orthographic projection, let me reproduce the figure that we have here. We'll be having this. Now, I have reproduced this figure here at the right hand side of the screen. So what we want to do, we want to draw the different views of this figure. We have three views. We have the plan, which is looking in from the top. We have the front elevation, looking at it where the arrow is pointing, which is RX. And we have what is called the end view, looking at it from behind or from in front here. I've drawn out the views. So when you talk about orthographic projection, you're talking about the views. Now, what are the three major views of an object or of a block? We have three views. We have the plan, looking it from the top, right? You have the front elevation, that is where the arrow X is pointing, as you can see at the right hand side of the screen. Then we have the end view, which is looking at this direction, right? So note one thing, wherever the arrow is pointing will be your front elevation. So since the arrow is pointing in this manner, this is your front elevation. Now, the first thing you do when you hear the word orthographic projection is to draw your orthographic axis. That means you draw your horizontal line this way. You draw the horizontal line this way. You can see that. And you also draw the vertical line this way also. Draw the vertical line this way. You see that? Sorry. Now, after you've done this, what you simply have to do now is you take your compass or your rule and you measure 5 mm up and 5 mm down, or you can use 10, whatever dimension of your choice, right? So we'll just measure, let's say 5, this manner, or 10. Let me say 10 or 5, any of them. I'll mark up, I'll mark down, I'll mark left, I'll mark right. You can see that. And I'll use my set square on my rule, and I'm going to draw this way, right? Because my main figure must not touch the horizontal line. You can see that. Now my line must not touch the center line. You can see that. So the first thing is, since we are told in first angle projection, you know very well that this is the first quadrant, right? Which we know very well, first quadrant. And this is the second quadrant here. This is the third quadrant. And this is the fourth quadrant. So if you are told to draw in first angle projection, if the side your arrow is pointing is either here or here, right? You say you are drawing in what? In first angle projection. Are you with me now? If your front elevation is either in the first quadrant or in the second quadrant, you are drawing in first angle projection. So since we are drawing first angle projection, since we are drawing first angle projection, I will either place my front elevation either in this point or in this point. But if I place my front elevation either in the third quadrant or in the fourth quadrant, I am drawing in third angle projection. So let's draw this. Since the question is telling us we should draw in first angle projection, so I prefer taking the second quadrant. So I'll just measure, since from here to here, what I'll be placing here will be the views of this block, which are what I just replicated. So when you're looking at it from this side, you're going to see this shape here. That's what I'm bringing out. And let me call it, if from here to here is 50, meaning from here to here is also what, 50, right? So here to here is what, is 50. I'm going to measure 50. So this point here will be my reference line. So I measure 50 from here to this point. 0 to 1 is 50. So I can easily just thicken it. Since it is sticking there, you can see that. Now what do you notice? From here to here, or from here to here, is the same as saying from here to here, and that is what, 20, right? So, and this point here is this point. Since it's facing this direction, whatever you do will face here, and this will be 22. So I'll measure 20 here. This is 20 here, right? And I'll taking it. Are you with me? Now the next thing is, at this point here, from here to here is given as from here to here, which is the same as saying from here to here, and that is what, 30. I'll just take my meter rule, my steel square, I'll draw an horizontal line. I'm going to measure 30 at that point. This is 30 here. And now taking it. You can see that? Now the same thing is from here to here, same thing as saying from here to here, and if you look at it, it's the same thing as saying from here to here, and that's 10. I'm going to measure 10 from that point downward. So let's just take my set square. And now measure 10 here. So let's measure the 10 from 0 to 10 here. And I'm taking it. Can see that? Now the same thing is, I'll just project this way. Also, so this point here you're seeing is this point here, right? And from here to here, since I'm saying from here to here, since I'm saying from here to here, and that is 20. So I'm going to measure 20 on my meter rule here. Measure 20. This is 20. And I'm taking it. Then I'll close it up since it is closed up in the question. So I'm going to close this point up. You can see. So I have reproduced this figure here. Since I've produced, so this is the front elevation, that's why I'm putting it at this quadrant. Now the next thing that follows the front elevation is the plan. So you need to know that the plan is always, in first angle projection, the plan is always under the front elevation. Are you with me now? In first angle projection, the plan is always under the front elevation. And where is the plan? This is the plan, right? So if you look at it, you know, when you look at this point from here to here, this side, let's say it is A, here to be what? A. If this side is B, here to be B, right? You're looking at it from the top. Now, if I'm looking at it, what I will just do here is I am going to project the point here, right? Look at what I want to do. So bring it down a little bit, faint line. All those edges I have here, I'm going to bring them down. Now, what do you notice? The end of this point here is the end of this point here, right? You can see the same line that is connecting them. So it means that from here to here is equals to from here to here, which is given as from here to here, and that is 50. So I'm going to thicken the distance from here to here. Since it's thickened, then you can see that I've thickened it. Now the next thing is, since from here to here is 50, which is are saying from here to here, and which are saying from here to here, right? So it means that the other part here will be the part from here to here. And from here to here is equals to from here to here, and that is 30. So my height here of the plan, which will be my width, is given as 30. I'm going to measure 30 from 0 to 3. Close that, and I'll close it up. Since it is closed up, from here to this one, then close it up to see that? Now what do you notice? This is already telling you, this line you're seeing, telling you that you see the line here that is closed. So that means I'm going to close it up this way. You see that? So this is A, this point is A, this is B, this point is B. You can see that? Now we've drawn the plan. Now the next thing we're going to be doing here is the end view. Right, the end view, looking at it from the front here, this is the end view. And what I'll do first of all, I'll use my 45 degree, place it on my set square, my T square, and at this point where they meet, from the center point here, where the X and Y meet, I'm going to draw a line this way. You see that? That is at an angle of 45 degree. Then I'm going to project all these points, the edges to that line, and also the edges to that line is already there. Then I'll just draw this here, and I'll draw that line here this way. And I'll start moving this upward. So this will, from this edge here, standing on my set square, I'll place it this way. You can see. Then I'll replicate what I have here. This is sticking from this point to this point. You see? From here to here sticking, because the thickness from here to here is the same thing as saying from here to here, right? And if you look at it very well, from here to here is the same from here to here, and that is 30. So you don't have to measure your 30. You just, they are connected. Now the next thing I'll do is this line here. I've already drawn the base, which is 30. The next thing is this here. If I project this to this point, here is closed. Just like here is closed. You can see that. And here also is closed. I'll close the rest point here. So this is what we have here. We have successfully reproduced what we have. You need to put in your dimensions as is shown on the figure. We know whatever you have here. This is 20, 50. From here to here is 10, just like we have here. So you do all your dimensioning rightfully. Is that taken now? So this is what we have. This is what we call the first angle orthographic projection. If these two come down here and these two goes up here, knowing fully well this line you draw here will be coming like this, right? They will call it your third angle, but the way it is here, it is first angle because the plan is under the elevation, right? Whenever the plan is under the elevation, it's third angle. And you know one thing fully well, that the end view is always in front or behind the front elevation. So we say this front elevation is the center of attraction. So if you have found this video helpful, please don't forget to subscribe, like, comment, and share. Thanks for watching.